Okay, so this is your homework help video for Unit 10, Lesson 4. As with all the ones that have preceded this particular lesson, this homework help video really is not designed to replace the notes video. It's designed to supplement it, right? So there are things explained in the notes video that if you're only watching the homework help video, you might not get that question answered because it's already explained in the notes video. This is for those who are wanting to kind of check one more thing, or have done their homework and just want to do a quick check of the answers before we release the answer key, something along those lines. Again, it's not replacing the notes. So if you have not watched the notes, you need to stop the video, you need to go over to the notes video and watch that first. Okay? We're going to do 4 here, one from the first group, one from the second group, and 2 in the last group. So number 2 is what I picked for the first group, number 8 for the second group. Number 2 says r equals 4 cosine of 2 theta if r equals 1. We are solving for theta, where theta is an element of 0 to 2 pi, which tells us that our answers are going to lie within this interval, and because we have brackets on both sides, our answers could be 0 and or 2 pi. If there was a parenthesis on one or both of those bounds, wherever the parenthesis was, that value would not be included, right? That's an open interval as opposed to a closed interval, okay? And so we're going to go ahead and solve this one. We've got r is 1, so I'm going to go ahead and put 1 into that r's spot. And we are going to go ahead and isolate our trig in this particular case. If there was something being added or subtracted to the cosine, we would undo that. For example, in number 1, I'll go ahead and give you a hint here on number 1, you would need to make sure you subtracted the 2 before you could do anything with the 5 or the sign, right? We're undoing order of operations, so we would undo the addition or subtraction first. Okay, then we can do the multiplication division. In this case, there's a 4 being multiplied to that cosine, so I'm going to go ahead and divide the 4 to the other side. Okay? And then we are going to go ahead and isolate the trig term. So in this particular case, that is that 2 theta that we are wanting to isolate, which means getting rid of the cosine. As I was grading homework, I saw quite a few students who were still wanting to divide the 2 out of the cosine. So we're wanting to make this 1/8 equals cosine 2 theta. There are parentheses around this 2 theta. So let me go ahead and show that, right? We don't write them, but they're there. They're in understood parentheses, just like, you know, if we have an x, there's an understood 1 in front of an x. 1x is the same thing as x. So there are parentheses there. Order of operations tells us we have to undo that cosine before we can undo the 2. And so we have to get rid of that cosine first, okay? Which in this case means arc cosining both sides, taking the inverse cosine to the -1 on your calculator, so that we can figure out what 2 theta will equal, right? And so if we did the inverse cosine of 1/4, so I'm going to go ahead and show that here on the screen, right? So we're inverse cosining both sides. It's going to cause that cosine to go away, leaving you with just the 2 theta. And then the inverse cosine of 1/4 equals about 1.318, 116072, etc. Right? So I'm going to put 1.318. Okay, but that is only one location. That 1.318 is the value of cosine that lies in the first quadrant here, right? This angle here is the 1.318. Cosine is not just positive in the first quadrant. Cosine is also positive in the fourth quadrant. And so we would need to figure out, well, how could I name that angle? I can't just call it 1.318. How can I name that angle, but using the value that I know, 1.318, that this angle measure here is equivalent. And the easiest way is saying -1.318. Problem with that is -1.318 it does not lie within our boundaries, right? And so we can't unfortunately call it -1.318. So you have 2 options here. One, you could say, okay, I'm going to go ahead and pretend for a second here that I'm calling that -1.318, right? Go ahead and write that. I'm going to pretend for a second here that I'm calling that negative 1.318. However, recognizing that I can't leave it with that name, I'm going to add 2 pi to that negative 1.318. Why would we be adding 2 pi to it? Okay, well, we'd be adding 2 pi because that would take this angle that we are currently naming in our fourth quadrant, and adding 2 pi would rotate it one time, one full rotation around our unit circle, landing us at exactly the same spot. And so you could call it negative 1.318 plus 2 pi if you wanted to. Okay? The other way you could think of it, in case you prefer this, again, they both work. They're essentially the same idea. Is saying, okay, well, I can't call it negative 1.318, but I know that this angle here, my right part of my x-axis, is called 2 pi. And if I subtracted 1.318 from 2 pi, so starting here minus 1.318, I'd land at this angle that I'm trying to name. Right, when you think about it, 2 pi minus 1.318 is the same thing as negative 1.318 plus 2 pi, right? So you're doing the same thing, it's just a different way of thinking through that problem. Both of them, whether you think of it as negative 1.318 plus 2 pi or 2 pi minus 1.318, you get, and these should be approximately 4.965. And then what we learned a couple lessons ago is that when you have a 2 theta in here, right, what we've just done is one rotation of our cosine. Well, because there's a 2 theta in here, that cosine is getting rotated 2 times. And so these angles are good for an initial rotation. I'm going to go ahead and put parentheses around that saying there's one rotation. I need to do my second rotation around cosine, which means, again, a couple lessons ago, pull out those notes again if you need to, it means adding 2 pi to each of these values. And so we'd be doing 2 pi plus that 1.318, which is approximately 7.601. And then 2 pi plus the 4.965, which would be 11.248 approximately. And there's that second rotation of our cosine. Okay? So now we have 2 theta equals our 2 rotations. If we now take our theta and divide each of these by 2, dividing the 2 across, we get approximately 0.659, approximately 2.482, approximately 3.800, and approximately 5.624. And then I truncated all of these answers. A couple of them, if I remember correctly, do round to one value. Like I remember this 3.800, or at least I'm pretty sure it was this one, rounded to 3.801. If you chose to round instead of truncate, that's fine. Again, I chose to truncate all of them. Okay? Okay, so if you are wanting additional practice with ones like these set and the ones in the notes weren't enough, and going over number 2 here wasn't enough, send an email to your teacher, let them know. I could use another one of fill in the blank, and we're happy to get that created for you to make sure you are good to go with this solving idea. However, you are going to continue to use this solving idea as we go forward with the rest of these, okay? Okay, number 8 was the one I identified for the second set. So we're going to be sketching both equations on the same graph. We're going to be finding the points of intersection. Okay. Okay, so graph first. Go ahead and give myself a little coordinate plane here. Go out 4. Actually, I'm going to go out 3. If I need to, I can always lengthen the graph. Okay, and then I myself always like to give myself my little circles for my polar graph. Oops. Come down a little bit lower on that one. Obviously, because I'm sketching this one by hand, the circles are not going to be perfect. But notice, directions do say sketch both equations. It doesn't have to be perfect. Okay, excuse me. Here we go. So r equals -2, r equals -2. I'm going to go ahead and graph that in red. R equals -2. Going back to your objective 3 notes, we know that this is going to be a circle with radius of -2. Obviously, a radius of -2 is a little bit interesting to sketch because it seems like that would be a challenging circle. However, remember that a radius of -2 is really no different than a circle with a radius of 2. It's just that each angle is going I should say, as you're plotting each angle's coordinate point, you're moving the opposite direction from that angle, but you get the same circle, right? So say we were graphing theta equals 0, which would be this x-axis. A radius of 2 would put me here. A radius of -2 just sends me to the reverse direction, right? Same thing with pi over 2. Pi over 2, a radius of 2 would put me here, up 2 on the pi over 2 angle. However, -2 puts me down here. Same thing with pi, goes the reverse direction, and 3 pi over 2. Okay? And so it's essentially the same thing as graphing a radius of 2, because again, kind of bear with me here, if this were to say r equals 2, well then we'd be moving 2 in the direction of each angle. Well, so 0, I'd be plotting a point here. What do you know? There's already a point. Pi over 2 would be plotted here, pi would be here, 3 pi over 2 would be here. And so you can kind of think of this as r equals 2 to a certain extent. I'll put kinda, because again, it's not the same. R equals -2 and r equals 2 have the same looking graph though, right? Okay, and then r equals 2 cosecant theta. Different ways of doing this. If you liked the table route from the very beginning of Objective 3, you could do it that way. I myself tend to turn it into x or y, I should say, into rectangular equations is my preference. I know some people look at this and are immediately like, oh, y, piece of cake, they got it. If you're there, great. I'm going to go ahead and walk through the steps of getting to the y for those who would prefer to do that. So r equals 2 over sine theta. Right, that's what cosecant is. If I multiply the sine to the other side, we are here. And then in objective 1, yes, objective 1, also objective 2, we looked at different relationships, and r sine theta is equal to y. And so if you go back to those objective 1, objective 2 notes, you'll see those relationships written in there. Okay? And so this would be y equals 2. And I'm going to graph this in blue here. Y equals 2 is a horizontal line through 2. Okay? And so I can see my point of intersection in this particular case. It looks like I have just one. Okay? So I'm going to go ahead and confirm that by setting these two equations equal to each other. So we have our -2, which is going to equal our 2 cosecant theta. Okay? Which means we have our dividing the 2, -1 equals cosecant theta. And if you're comfortable knowing what angle value gives you a cosecant of -1, great, go ahead and write down that angle. For those who are sitting there going, cosecants, I'm not so sure about that. Well, you can do a reciprocal idea, right? Or spinning the fractions. Some people think of it that way, but that's what a reciprocal is. And so you could take the reciprocal of this cosecant theta, that would be sine theta, and you could do the reciprocal of -1. Now, imagine what this is as a fraction. That's -1 over 1. If you spin that fraction, if you do the reciprocal of -1 over 1, you still have -1. The other way you could think of this is turning this cosecant theta into 1 over sine theta, and then multiplying the sine theta over here and dividing the -1 to the other side. It's a different way of processing those steps. Okay? Well, there's only one angle between 0 and 2 pi where sine theta equals -1, and that is at 3 pi over 2. Okay? And so remember, with points of intersection, we are going to write it as a coordinate point. So we have our 3 pi over 2 here. Question is, well, what is my r? If we didn't know what our r was already, we'd be taking that 3 pi over 2 and plugging it into our equations to solve. And I tend to recommend plugging into both equations, if applicable, so that you're double checking, like, do I get the same r in both cases? If I don't, well, then I'm questioning my answer, looking to see if there's something that I did wrong. In this particular case, though, we don't actually have to plug in because they tell me what my r equals. Look at what my r equals. My r equals -2. And then you could always do a quick little eyeball double check of the point you had just identified. Where would the polar coordinate -2, 3 pi over 2 land? Okay, well, 3 pi over 2 is this downward facing quadrantal. -2 as a radius would send me the opposite direction, like we learned in objective 1, and so that would send me 2 backwards, and sure enough, I land at my intersection point between my two graphs. Okay? Okay, 2 more here. Numbers 12 and 16 are what we are going to do, which is honestly more of what we've already been doing. We're going to start by sketching each system on the graph, and then we're going to solve the system. Okay, so let me go ahead and give myself a little coordinate axis here. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And then just because I don't want to draw all the circles for now, I'm going to draw the ones that pass through multiples of 3. And if I need to, I'll add in the rest. But it just gives you something to kind of shoot for. Okay, so graphing here. First up, we have our r equals 3 plus 3 cosine theta. So again, you're looking at your objective 3 notes if you need a reminder of graphing these functions. 3 plus 3 cosine theta, we have a plus minus, which puts us in that cardioid limousin realm of, I should say, family of functions there. And so we're thinking about whether or not we have an inner loop, where our shoulders are of our graph. We're thinking about which direction our cardioid or limousin, depending on the graph, is going to head. And so you're starting to kind of re-trigger all of those things that we learned in objective 3. Okay? So first up, we have a positive cosine that we are looking at here. So positive cosine, which quadrants is cosine positive in? Cosine is positive in the first and fourth quadrants, and so that tells me that that is the way my graph is going to go, or my shape is going to move into the right first and fourth quadrants. We see that we have a 3 plus 3 equivalent A and B there. And so if I were to subtract those, I'd get 0, so I know I'm not going to have an inner loop. Okay? And so then my shoulders in this particular case, actually I'm going to graph this in red, kind of make it match number 8. My shoulders in this particular case would be at 3, so we're going to get 1, 2, 3, 1, 2, 3. Adding those together for my max point out here, 3, 4, 5, 6. 3 and 3 make 6. Okay, and so we've got our cardioid here. Again, rough sketch, it doesn't have to be perfect. Cardioid limousin. No inner loop, so it's going to come up and kind of go there. Okay? It's probably actually a little bit rounder than what I drew, but again, it's a sketch. Okay? And then we have our r equals -3 cosine theta. Okay, and so we have here, oh, nope, I did red on the last one. Let me do this one in blue. Okay, so r equals -3 cosine theta, excuse me, is that one pedal idea, right, with our negative cosine, so we're going to be moving to the left-hand side, right? Let me draw that here. And then this one's going to be a circle. We've got that 1 theta inside, right? And in this case, our r is going to be 3. And so I'm going to be starting here at the origin. I'm going to be moving 3 out in the negative direction, so 3 to the left. And then this is going to be a circle. So I'm going to go ahead and eyeball my 1.5 and 1.5 there. And I've got a little circle. Okay, and I can see a couple intersection points here, which I'm going to go ahead and draw in a little darker. Okay, because again, we're going to be solving the system, which is, as you heard in the notes, essentially the same thing as finding points of intersection. Okay? Okay, so finding those points of intersection here, we're going to set our two functions equal to each other. So we have our -3 cosine theta, which is going to equal our 3 plus 3 cosine theta. Okay? Let's go ahead and isolate our trig. So I'm going to subtract this 3 cosine theta over here to get -6 cosine theta. Dividing the -6, we get cosine theta equals -1/2. And then looking for what your theta therefore would equal, we're looking for, first of all, what makes cosine equal 1/2. Okay, we'll think through your angles, draw your triangles, unit circle, hand trick, however it is you do it. Cosine is 1/2 at your pi over 3 angle. And then what would be the pi over 3 angles that would create a negative cosine? Remember, cosine is negative in the second and third quadrant over here on the left. And so that would be at 2 pi over 3 in the second quadrant and 4 pi over 3 in the third quadrant. Okay? And so then our angles, or sorry, our coordinate points here would be at, whoops, R first. Theta of 2 pi over 3 and 4 pi over 3. Our R, in this case we aren't given an R, so we are plugging that in. 2 pi over 3, cosine of 2 pi over 3 is -1/2. By the way, you know that not only from your hand trick and unit circle and all that, but because that's how you got the 2 pi over 3, remember? We asked ourselves what angle has a cosine of -1/2, and we answered 2 pi over 3. So therefore, the cosine of 2 pi over 3 is -1/2, or it should be. If it's not, then we're double checking all our work, right? So cosine of 2 pi over 3 is -1/2 times 3 is -3/2. -3/2 plus 3 is 3/2. And again, I always tend to recommend double checking with your other equation as well, just to make sure you still get 3/2. Cosine of 2 pi over 3 is -1/2. -1/2 times -3 is 3/2. And we're good to go. Okay? 4 pi over 3, same thing. Cosine of 4 pi over 3 is -1/2, which therefore is going to generate the same value because both of these gave us a cosine of -1/2. Oh, excuse me. Goodness. Okay. There we go. Last one here, number 16. We have our r equals 1 minus sine theta, r equals 4 sine theta. Let's start with our sketch here. Okay, and I'm going to go out. Let's just go out 5. No, I'll go out 6. And then again, I don't want to draw those circles, so because I'm seeing some multiples of 2 here, I'm going to do my circles at 2 for this one. And again, if I need to add in some more circles in a bit just to help my graph, I can. Okay. So first up, we have our r equals 1 minus sine theta. We see that plus minus puts us in mind of the cardioid limosome family. Thinking about which direction you're going to be headed here, we have a negative sign involved. Okay, well, which quadrants is sine negative in? Okay, sine is negative in the third and fourth quadrants, and so my shape is going to be going down into the third and fourth quadrants. We have no inner loop here because we have a 1 and 1. 1 minus 1 would therefore be 0, so no inner loop. Our shoulders in this case are going to be at 1 in either direction. So 1 and 1. And then 1 plus 1, our bottom point is going to be at 2. Or again, one more time, if you liked the idea of doing a little XYT chart, or in this case, theta R T chart, you could always do that as well. Okay? And then R equals 4 sine theta, R equals 4 sine theta. We don't see the plus minus, so we're thinking more in the pedal realm. This one, we've got our 1 theta, so we know it's going to be a circle. Circle of radius R in this particular case, or sorry, radius 4 in this particular case. And it is a positive sign, so what quadrants are we going in with our circle? Okay, our circle, therefore, is going into the first and second quadrants. We're going up with our positive sign. Okay, and so we're starting here at the pole, going up 4, and then radius of 2 in either direction. Should be kind of there-ish. So not a great circle, but close enough. You can at least see a couple intersection points in here, which I'm going to further notate. Okay? Okay, and then finding those intersections, setting these equal to each other. So our 4 sine theta is going to be equal to our 1 minus sine theta. Adding this sine theta over to the other side, we get 5 sine theta equals 1. Dividing the 5 then, we get sine theta equals 1/5. This is going to be a calculator one because I don't know about you. I don't know what angle gives me a sine of 1/5. Okay, and so I'm going to go ahead and take my calculator, do inverse sine of 1/5, and my calculator is going to tell me that that's about 0.201. Okay, and so this brings us full circle to where we started at the beginning of this little homework help video, the beginning of your notes for this lesson, which is great. That is one of my angles, but if I were to do a little sketch of that, 0.201 is only the angle in the first quadrant here, this 0.201. Sine is positive not only in the first quadrant, but where else? Okay, it's also positive in the second quadrant, so we need to figure out how do I name that angle in my second quadrant using the one piece of information I know, which is that this little distance here is 0.201. Okay, well this left-hand side of my x-axis is pi, and the angle sits at a distance of 0.201 from pi. It's 0.201 less than pi. And so I could find that angle there by doing pi minus 0.201. Okay, and when you do that, you get right around 2.940. Okay, and so then my two angles are 0.201 and 2.940. What is their radius? Okay, well, taking that 0.201, plugging it in, you could use your calculator if you wanted to, but remember what we talked about in number 12. We already know what the sine of 0.201 is. I got 0.201 because I asked, what angle gives me a sine of 1/5? Okay, well, that angle gives me a sine of 1/5. That was our answer. So therefore, the sine of that angle is 1/5. 4 times 1/5 is 4/5, or 0.8 for those who are using their calculator. Okay, same thing over here. Okay, and that's number 16. Okay, if you have any questions at all, remember, email your teacher. We are still here to support you, but that's your homework help for Unit 10, Worksheet 4.